Hello, my name is Gursimran Singh. Today I'm gonna cover Traefik Reverse proxy, how we can use it in our systems, what are the basics of it, and why do we use it. Let's start out with what Traefik is and why we're here. So Traefik is a company which makes several products. If we go to their website, it says it's a cloud native networking platform. It supports deployment in major cloud providers, as it's free forever, which is much better. But this doesn't really explains what this little guy is doing over here. If we go over to the products, we see there are Traefik Enterprise, which is like a paid version of Traefik, and we have got Traefik Hub, where provides like cloud native networking platforms. But what we're interesting here is in the solutions, the open source part of it. And we'll be talking about Traefik proxy here. And if you guys don't know what a web proxy is, they really do a nice job in explaining what Traefik proxy can do for you. It simplifies the networking complexity while designing, deploying, and operating applications. This is how the Traefik web proxies dashboard looks like. As you can see here, we have got some entry points. Entry points mean whenever a new request is sent to this proxy, what would be the gateway? So could it be port 80, which is HTTP, or port 443, which is not listed here, but it could be the HTTPS, as we all know, encrypted, or port 8080, which is to access this dashboard, which is an entry point. This would all make more sense as we go along, but this is a major upgrade from Traefik V1, which used to look like something this. So we have the front ends and the back ends, but in Traefik V2, we have got entry points for HTTP. This is the protocol, and it's TCP, and routers and services. So front ends and back ends replace routers and services for those who have worked with Traefik V1. Let's talk about what Traefik is. So Traefik, as I said, is a reverse proxy. What is a reverse proxy? The question is a nice question, right? A reverse proxy basically helps the load balancer that makes deploying microservices easy. So here we have the Traefik architecture diagram. Here is the Traefik proxy guide. For example, I'm Bob, right? So Bob wants to reach api.domain.com. He goes to this browser, hits api.domain.com, and it hits the reverse proxy. So reverse proxy has like several advantages. It can prevent your website from DDoS attacks, can give you like better security, a way to automatic and dynamically route people to different services, and also authenticate your domain with SSL certificates and all of the good stuff. As I was telling you the example, api.domain.com, the user visits the website. Traefik has the certificate for this website, and it does the DLS negotiation, and if the website is encrypted, then Traefik has the routes for this domain to reach out to a specific service. For example, let's say api.domain.com has to reach this web server, which is, I don't know, in your compute, could be running in Kubernetes, could be running in Docker, could be running on your local environment, on a physical machine, who knows, right? So what it does, its basic job is to route domains or hosts to different services. So what are the advantages of doing this? Let's take another example. So here we have backoffice.domain.com. Traefik has the configuration to know. So by the way, Traefik can run either on Docker, on local machine in your network, and it can serve all the SSL certificates. It can do all the routing for you without any problem. So backoffice.domain.com, you go to the browser, this go to Traefik. Traefik has the route for it, and it goes to the API server and gets the response. And let's see, Traefik, there's a nice article by Cloudflare, what is a reverse proxy. It protects web servers from attacks and provide performance and reliability benefits. Forward proxy, on the other hand, is a remote computer. It forwards the proxy to the internet, and the internet basically does that. What a reverse proxy does is any number of user home computer, they straight away go to the internet, and just before where your service is hosted, you have a reverse proxy, and it acts as a safeguard for your whole network. And this way, bad actors from the internet can't really have access to your servers directly, which is just protects your servers from attacks. And what it does is also help. It can load balance for you. So load balancing is a way where, in these days, millions of users every day want to reach out to Amazon.com to buy stuff, right? So a poor machine can't just get all this load from all the users on the planet Earth. So it's better to balance the load. So reverse proxy can help balance the load by routing requests. Could be in round robin, or could be in different fashions among different servers. And there are like several other benefits in reverse proxy that we can use, and Traefik allows us to do that. And the way it allows to do that can be explained more if we open the Traefik proxy page. So let's click on get started, and here we have the Traefik proxy documentation, which is to be honest is a bit confusing, but as we go along it can make sense in the long run. Again, it says it's an edge router, and the list goes on. What I wanted to talk about next is how do we configure proxy server. So okay, we have it installed on a machine or in a Docker container, which we saw in one of the other places. Here's the Traefik's official image, and the way you can install is basically use this Docker configuration backend, and you run the Traefik this way, and then you can have different rules in it and all of that good stuff, right? So how do we set up the rules in Traefik? So in order to set up the rules in Traefik, we have got 3 things to set up here. As you can remember from the diagram, we have routers, we have services, which are the backend services, like where our application code resides. Routers are something that are rules basically to match these hosts to which service. And middlewares is where the fun is happening. So middlewares can help you protect your website from DDoS attacks by rate limiting every request you get. It could help you by providing HTTPS connections, SSL certificates, and all of that good stuff. So everything is listed over here. We can go there one by one. Let's start with routers. The routing and load balancing. What's happening to the requests? So when you start Traefik, you define the entry points, and what an entry point is very well put in this example here is in their most basic form. They are just port numbers, right? And the way the port number works is, so you have these port numbers. As you can see on the left hand side, you have port 80, which is for HTTP, port 443 for HTTPS, and port 8080, which is a Traefik port. There should be a way to configure this, but let's start with port 80 and 443, which is widely used on internet. So port 80 is HTTP, which is not secure. And whenever a website wants to access a host, for example, Amazon.com, like without the HTTPS, like http://amazon.com, it goes there, and you see that there's a redirection going on, which could be achieved using middlewares in Traefik, but that's for later part. What's going on here is a reverse proxy could be installed, for example, on Amazon.com infrastructure, which routes it to the correct point, right? So the entry point basically here in HTTP case was 80. Since it did a redirection, it went to 443. It makes sense. And so now the point of entry is web secured, which is 443. And now once it is inside the Traefik's domain, incoming request is in the Traefik application from the entry points, what I'm listening to. So from port 3, the request came, and now it goes to the routers, you see. And the routers have rules, consist of 2 things. They have rules. What does the request look like? We're gonna be matching that request with all the rules we have, and then we're gonna apply any middleware if necessary on it. We're gonna tweak the request response, and then pass it on to the service we want. Where's the feature, servers, load balancing, all that good stuff. and it calls the machining server. That's how the traffic proxy basically works. Now, clear responsibilities, providers, entry points, routers, services. We already talked about entry points, and providers are basically the services that live on your infrastructure, their IP, health, and all of that. If I open providers, we've got a provider could be any configuration, a way of configuring your traffic basically. So you can configure traffic using ECS, Nomad, Console, Kubernetes, Docker, file, or a good old configuration file, which looks something like this. It could be a YAML file, it could be a TOML file, it could be a CLI. If you end up using, I don't know, Zookeeper or even Redis, then the configuration files look different. Here we have, for example, for Redis, there should be a key value store configuration. This is how we configure the provider. What's the Redis endpoint? What is the root key in Redis? Where we're gonna look all that information, and we're gonna connect to it, and how we're gonna store everything. So we will be talking more about how we can configure it, but let's cover what the configuration basically looks like. Starting with the routers again. So we were here, right? We know now how the request comes. It goes to the entry point of traffic. It goes to port 443. And now we inside traffic. So here they give an example of how the router looks like. And let's do YAML and using the file provider, since this is the, I guess, the old and the traditional way of configuring traffic. And this is a static this is a, again, there are like two types of configurations, static and dynamic. We'll talk about it after we cover routers and middlewares. The dynamic configuration is it's configuring a router for HTTP. So as you can see, there are like different protocols for which we can configure stuff, which is, first one is HTTP, the second one is TCP, and there is also UDP, which is not like enabled in this image, but we can do that as well. And here you can see all the providers where it's getting the configuration from. It could be Docker, Marathon, Kubernetes Ingress, Kubernetes CRD, Rancher, and enable logs and all of that good stuff. Here we have a router rule. The rule is called my router, and the path is /foo. So this is what's gonna be matched when a host hits traffic. If I were to explain this with the diagram, and this would look like something like this. So I have a host called my local laptop machine, right? And I have a local laptop which goes to the internet, and you know, they just want to reach out to a website called bobthebuilder.com. Now the bobthebuilder.com has a DNS record which could point to our hosted traffic instance. For example, our traffic instance is hosted, and the domain name registered for that machine is traffic bob.com, right? So we have this DNS entry which maps like this, right? So my local laptop goes to bobthebuilder.com, which has pointing to traffic bob.com, where we have hosted our traffic machine, right? So when you host this, so let's take an example of this rule, right? So this rule will be matched when you hit the traffic endpoint, but at this path, which is /foo. So if we hit, if the traffic is configured with such a router rule with the path /foo, if you go to bobthebuilder.com/foo, it will which is pointing to the traffic instance. So you are at the reverse proxy already, which is this point. You are incoming the request to the proxy. It goes to the entry point of the request. So here, since we didn't mention HTTPS, let's say it's an HTTP request, and it goes to the HTTP entry point, port 80, goes to the router rule matches /foo, and traffic is gonna return that or route that request to the service foo. And the service foo, we can right here, service foo, which is hosted, could be hosted anywhere. It could be hosted on AWS, it could be hosted on your local machine, it could be hosted anywhere. So the job of traffic is to, when the user goes to this location, is to route it to the proper service. Now, during that transfer of data from my local the request from my local laptop to the service foo, so we might be interested in making some changes to the request that comes in for various reasons, right? So in this case, this is the router rule, right, which is written in the traffic configuration. Service foo is the service which could be defined again. Let's take an example here. HTTP service, those services, my service, and it could be load balanced among different servers. So let's, in order to demonstrate that, we could have like a service foo 1 and a service foo 2, right? And this is how traffic can easily help us load balance our request to service foo 1 or service foo 2 and it has like tremendous advantages on high availability and in gaining low latency and all of that good stuff. So this is how the services look like. But I was saying, during the request from our local laptop to the service, we might be interested in checking the request if it's malicious or not. Could be anything. It's a wide internet, right? That's where middlewares come into play. So after the routers have, between this router and service thing, so we can also specify the middlewares. Let's look at some examples of middlewares now. So as I was saying, in the routers, we could process middlewares like middleware 1, 2, 3, and then the request could go to the service. Attached to your router, pieces of middlewares are made of tweaking the requests before they are sent to your service, right? Now, here they have taken an example of the file provider, which is like much easier to understand. So there are different ways to configure this, but in this video, let's take an example of file. Here, the HTTP, protocol has a router, as we created earlier. Our router name was my router, and it was going to my service. But in this case, our router name is our router. Let's grab that quickly from there. So here, if we go to routers, we have this configuration. Let's align this way. And this is how our routers look like. Right? This is how our routers look like. And we have our service. And here we have service foo. It's load balancing basically between service 1 and service 2. Just an hyphen here so that we don't have any confusion in our YAML. No syntax errors. And since it's like a list of stuff, let's add it as a list. So list item 1 is service foo 1, and list item 2 is service foo 2. And similarly, we define those services in the configuration example, declaring an HTTP service. I'm going to just copy this for the sake of this video. And I'll align it. Perfect. Of course, here the servers are not, These are the two servers, and the service name here is service foo1, and similarly we have the service foo2. Okay. No, so in this configuration we have a router, we have services, and we have two services, and we have one router. So here this diagram says we have a router. Whenever some URL hits traffic, goes to path foo, it'll route to either service foo1 or service foo2, and the services are defined here, which are load balancing among two different servers. So if the request decide to go to service foo1, it can either go to this URL, private server IP1 or private server IP2. If it goes to service 2, which is this one, it can either go to this URL or this URL. This is how we load balance stuff. Now, since we have this example ready, let's talk about middlewares here. So as I was talking about, that between this router and the server service, we might be interested in adding a middleware. And there are several middlewares in HTTP for HTTP and TCP both, and a list of HTTP middlewares can be found here. So let's see an example of middlewares. Here we have the router, right? Here the rule is different. So here, instead of just matching the path, which is /foo, they are matching the host itself. So this host could be example.com. So in this case, if you go to example.com, which points has a DNS entry to Traefik server, it'll route to, in this case, this service, which is service 1, which is load balanced among just one server, and the middleware is foo add prefix. So what they're doing here is, so middlewares in Traefik, they are already created, some of them, and you can also, use community middlewares, which we can cover later on. And here the middleware foo add prefix is adding a prefix /foo to example.com, and this is how it's set up. So the way it does it is using this add prefix middleware. If I search for it, which is named add prefix, I see this add prefix middleware. Opening it in a new page, has a nice documentation on how this works. The request comes in to domain bar. In this case, the domain was example.com, and example.com comes here. We add the prefix /foo to it. It becomes domain /foo/bar. In this case, it'll be example.com/foo. So why we want to do this? So maybe you decided to add a page /foo where your index page resides, or you just want people to land to /foo instead of your main example.com in this route. It's up to you how you want to configure it. And configuration, every middleware has a configuration example on how you can configure it. Here, for example, if you go to file provider, so here they're telling us how we configure this middleware add foo with the name. This is any custom name we can give, and this has to exactly match what is listed in this table here, and then we add the prefix foo, and it's all shown up here how it looks like. Similarly, they had like different what do you say, middlewares to manipulate the request itself. Another example that I can take is you might be interested in only allowing people from a particular list of IPs to hit your or basically reach out to your website, your service foo1 and service foo2. Okay, I just want my local laptop, so I just want my local laptop to be able to connect to my service flow, right? How can I do that? Let's take an example here. Like, so my local IP is, I have an IP before, for example, 52.1.224, oh sorry, 44.23, for example. This is my local IP. And I don't want anyone else on the internet to reach out to my service. How can I do that? I can use this middleware, which is, so if I go to file.yaml, copy this middleware, right? Add it to the configuration in my Traefik instance, right? I should be able to do it without a problem. Here you go. Add middlewares. Right? So what does configuration says? I'm just want to whitelist this IP. This is the only IP I'm interested in. Rest all of the ranges, I don't care. Right? Just remove this other entry as well. And we're done. So this says I have a middleware called test IP whitelist. It just has IP whitelist source range to be 532.1.44.23, which is my local IP. All the other requests to the server, to the Traefik server, will be rejected, and only my local laptop would be able to connect to these services. How cool is that? Like a simple configuration change, and you can do wonders with it. Now we can use different configuration options as well for every middleware, as I said before. So source range, we already set source range to be this IP. It takes a list of IP ranges in YAML, or could be, this should be cited notation. The other configuration we can set is IP strategy. So it has two parameters and it has depth and all that fancy stuff here. They give an example. IP strategy is basically tells the traffic to use X forwarded for. So I was out of the scope of this video, but there are like hundreds of other plugins and middlewares, community plugins, community middlewares that we can use in Traefik to achieve what we want to achieve. Community middlewares are also there. If these don't do what you want to do, then there are like several other middlewares that you can choose from, like IP2 location plugin, add geo headers, store block store exit nodes, and this lot we can do with Traefik. But what I'm missing in this configuration is I haven't set to use this middleware in my router, and the way I can do is either in the entry point I can do that, which I haven't created as well. But creating entry points is the first thing we'll do, and we can do that in the, let's see where the entry points are. So here we enter entry points, port 80 and HTTP. This is how the entry points basically look. And let's add the entry points here. We have got a web entry point and an address entry point, which goes to the static configuration. And routers can use those entry points. We can also specify which routers and our work on which entry point. By default, it uses all the entry points. So any request, if it comes to port 80 or 443, will be routed using this router, because by default it uses both, creates rule for both the entry points. And in order to use this middleware, which is test IP white middlewares, I go to the routers. There should be an HTTP middleware section here. Middlewares are applied in the same order the declaration. Using the file provider, it shows how we can assign middlewares. We already have a rule here, the path. And in order to assign a middleware, we just need to add a middleware key here, and then add the name of the middleware, which we defined in the middleware's place, right? And it should be aligned because it's a YAML, and it should be aligned just below the rule. right? And this is how I'm simply able to block all the IPs and just whitelist this particular IP for my route to from my local laptop to the service using Traefik. So this is all theory. We'll talk more about it in the next video on how I can achieve such a configuration using Traefik, and we'll talk more about entry points here as well.